before that, we will discuss a packet flow with some routers. Okay, so let's assume we have a router 1 here, we have a switch over here, we have a switch over here, right? And we have one more PC connected here, we have one more PC connected here, one user connected here. So this has IP address 10.0.0.1 on slash 29, 10.0.0.2 on slash 29, 10.0.0.3 on slash 29, 10.0.0.9 slash 29, 10.0.0.10 slash 29. Okay, so I hope like this concept of like slash 29 is clear to both of you, right? What is this thing, correct?
Yes, yeah. I mean,
so I have just done a basic subnetting here and just using the same subnet for all these interfaces, right? Nice, cool. Okay, first of all, just tell me one. Let's suppose here we have a user, okay, and that has IP address 10.0.0.4 on slash 8, and this user want to do a communication to which user? So this user is want to do a communication to the address 10.0.0.10. So just one answer in yes or no, so like that communication will be successful or not. And they have the default gateway address. The default gateway is 10.3. Everyone knows about this part. So 10.3, 10.3, 10.3 is the default gateway, and this user want to do a communication to 10.0.0.10, right? So just tell me, like this communication to this user will be possible or not?
We have a route and everything, or
that's a router, so we do not really need a routing protocol over here, right? Because both subnet is connected here, right? These users are having IP address and default gateway. So on the users, we just need a default gateway to send the packet out, right? And this also knows about default gateway, that is 10.9 default gateway. Okay. So now the question here is, whenever this user will be doing the communication, so that will be successful or not?
It's /8, it's 29. Yeah, it's possible, like a router will take care.
Okay. So Gursim, like your answer, yes or no, like it will be possible or not? You can put your answer in chat. And okay, so if this user will do a communication, so that is also possible because they have a default gateway and they can do the communication, right?
Yes, correct.
Okay, but not correct. This is wrong. Okay, just tell me one thing, why you are saying this will be possible to this user, or why you're saying like the packet will be going to this router, just because that is on another interface, that's why?
No, okay. So I got it, like, yeah. So why it's not possible? I mean, it's because the subnet masks are not different, like the segment is segregate. I mean,
Okay, no,
separated.
yeah, that is fine. I just want to know here, why you have chosen this answer like this will be possible, just because that address present in this subnet and this address in this subnet, and that has a default gateway, right?
Yeah, correct. Yeah.
Okay.
So
Okay, so basically I can see this complete design, but whenever, let's suppose I do have a single PC, let's suppose I don't know this design, right? I do have my PC only in front of me. Okay, let's suppose I do have a CLI. Okay. I have this CLI, right? Now, I don't know about this network. Okay, what is my IP address? That is 10.0.0.3 on slash 8 it has. Okay, and what I'm trying to ping here, I'm trying to ping to 10.0.0.10, right? So the device don't know, like I need to send this packet out to default gateway or to where I have to send, right? Because if I do not see the diagram, right? If I do not check the diagram, I don't know where that is connected really, correct?
Correct.
So for this user, the complete world is just this CLI. That's it. The user don't know, or we can say the complete world is just and the default gateway. Only user is having this information only, right?
Correct.
That user don't know that is connected to other interface of the router. So I need to send the packet out here. That information this user really do not have, correct? I can see this diagram. So by checking the diagram, I can say yes, that should send the packet out here. But in this case, what it will do, whenever I'll just note down few lines.
So in this case, like, I mean, the send traffic is possible, but the return path is not available, right?
Nothing is possible.
Yeah.
Let me just complete. Then you can ask your question.
Yeah.
Whenever a user PC try to ping any address, first of all, it will do AND operation, okay? And if the condition gets true, it will send the, first of all, we need ARP request, correct? Because I should have a MAC address to reach the address, then only I can send the packet out, right? Because all the layers should be fulfilled, right or wrong?
Correct. Yeah.
Okay. So if the condition gets true, it will send ARP request directly to same IP. Reason being, I'll tell you the reason. Again, and if the condition gets false, it will send the ARP request to default gateway. Now the user don't want to get the MAC address of the 10.0.0.10. No, I don't know. I don't want to get the MAC address of the IP this time because the condition get false. I'll come to this point why this is false, why that is true, right? If the condition gets false, right, the device will be sending the ARP request to only default gateway. It will say to default gateway 10.0.3, please give me your address. I do have something to send to you, right? Please give me your MAC address. Okay. So default gateway IP address. The reason I'll tell you now. Okay. Now what is that reason? So what is that condition or what is that AND operation? So it will see what is my IP address, that is 10.0.0.3.4, right? And I do have a subnet that belongs to 25.0.0.0.0. It means what is my complete range that starts from 10.0.0.1 that goes to 10.255.255.254, right? So this is the complete range if we have /8 value, right or wrong? These are the valid IP address range that belongs to this subnet, correct? So this user is having this idea. I do have IP address 10.0.4 with a mask of /8 and the complete range belongs to this range, right? It means I am the part of this range, correct?
Correct.
Now, the conditions, if destination belongs to same network, if destination belongs to same network, so it means now the condition gets true. If destination sorry, if destination belongs to same network, so that will think that destination is connected on the same switch, right? Because that belongs to the same network, so that should be in my network, right? Correct. Now if I see here 10.0.0.4, sorry, 10.0.0.10, the destination is belongs to this valid range, right or wrong?
Yes.
Correct. So it will say, okay, if that address belongs to my same subnet, it means that is somewhere connected on this switch. So I will be sending the packet, the ARP request directly to the same IP 10.0.0.10. Please tell me your MAC address. I want to send something to you. So in this condition, whenever this user will be sending ARP request locally here to to 10.0.10, that will never get any reply, right? Because the user really present on the other segment. So in this condition, this user will never get any MAC address for this IP address, right? And the packet will be dropped, all the packets. Okay. Now,
Yeah.
if let's suppose, if I talk about this user now, okay, now the condition will be false here. That says my IP address is 10.0.0.1 and my mask is 255.255.255.248. It means the range belongs to me is 10.0.0.1 to 10.0.0.7, right? This is my complete range that I have, or we can say this is the user belongs to this subnet. And now this user is trying to communicate to 10.0.0.10. That says no, that is not the part of my network, right? Because this subnet is after 7, correct? So this will say that condition get false, right? Now
Yes.
I need to send a ARP request to default gateway this time, because if the destination does not belong to my same subnet, then I need router help to communicate, right?
Yes.
So the router will be having the complete routing table, right? And that can give me the answer. So this is the reason here we never check the diagram. We just check what subnet we have and what destination we are trying to communicate. So this happens in this condition. So whenever these two users will be doing a communication to 10.0.10, that will be successful. But whenever this user will try to do a communication, the even ARP request will be dropped in this diagram, okay, in this network.
Yeah.
Now
That
you're
makes
done.
sense. Yeah, it's clear now. But I would just want to know, like, how that, like, so even the end user will act like a router, like based on subnet mask, or like, so it will prepare the like the route table, or like when it's /8, all requests coming to that belong to that subnet. It will not forward to the gateway. Apart from any other subnets, like. Whatever, it may be a default route, like apart from 10 dot, it will send to the gateway, right?
This time apart from 10.0.0 subnet, right? 10 subnet apart from 10 subnet, it will send the packet out to default gateway just like a default route.
Okay, so it works based on the route table in the system, like.
Yeah, definitely, because even the device has a route table. This laptop itself has a route table, right? And this is the
Yes, yes. Okay.
I really don't know the command right now, but we have a command.
That is in Windows, route print
Route.
space print.
Yeah, exactly this. So if you see, this is just like a Ceph table, right? In a Ceph
Yes.
table also we get something like this, like we have a destination, we have the
Yeah.
exit interface over there, right?
Yeah.
So if you see, this is the routing table of the device.
Yeah. Yeah, I got it. So yeah, so every request will not go to the gateway, like, when it's apart from that. Uh,
Then only.
So the remaining part of the AND operation will go to the remaining subnets, will
Right.
request to the gateway. Yeah, okay. So I'm confused then. Yeah. So it's not auto operation, like subnet mask is very important. um, yeah, Neeraj, I can't hear you. Okay.
Bro, just 1 minute. I'm just on a call. Just one.
Okay. Okay.
Okay, so I hope till this point everything is good, right?
Yeah.
Any questions if you have any questions? If no, then I'll move to the ARP request reply that mechanism. Okay.
Yeah.
Cool. So now I'll just draw the same diagram again, and we'll see like how the ARP request reply will be working in this diagram. R1, we have a switch connected over here. We have a user connected over here. Another user. This has 10.0.0.1/29. This has 10.0.0.2/29. This has 10.0.0.9/29. This has 10.0.0.10/29. Right. Now I will try to do a communication from this user to this user. And first of all, one more thing. Whenever you see, let's suppose you have two users in the same domain, right? Same domain, it means like they are connected to the same switch, same broadcast domain, right?
Yes.
So at that time, if let's suppose by mistake, if I will configure the same IP address on that user, so they both will be getting some kind of confliction over there, or we can see a dialog box here in the right hand side that someone is using the same IP address, right?
Correct.
Okay. So do you know what mechanism we have behind this? How we get, how my PC will get to know about this part?
It's whenever we switch on, like it will search for any conflicts in the same.
Okay, it will search any conflict, like what mechanism I'm asking. Like it should have some
GARP,
right?
GARP, yeah.
Sorry.
GARP packet, right?
Exactly. So whenever we give any IP address on the user, right? Let me just note down this point. Whenever any user PC L3 switch interface router or any L3 device, gets IP address. Now IP address via statically, via DHCP, via IPCP, via triple P, or via any other feature, right? So whenever any of the L3 device gets any IP address via any method, right, they basically try to check the duplicate IP address in the same broadcast domain, right? And how they do that? They send gracious R to same broadcast domain, and if someone is having that address, that will give me a reply. Otherwise, that will drop the packet. Okay. So in this condition, what happens here? Let's suppose no, I will not count this one now. Okay, I'll just draw this diagram. So whenever this user, let's suppose I will provide the IP address over here, right? This user will create a new packet. Now, how that packet will be look like? It will add gr. This is your gr packet. Okay, it will be having the sender IP address. Sender IP address is 10.0.1. Sender MAC address, let's suppose that is A. Target IP address. So tell me what target IP address it should be.
In order to find the duplicate means it could be same IP.
Exactly, absolutely correct. And what will be the destination IP address? Sorry, destination MAC, the target MAC address.
Right now we don't know what device. It's like for checking. It may be like broadcast MAC, like FFF.
It's broadcast, exactly correct. Because right now what I need here, we need to send the packet out, or we if you see here, it has to do a broadcast in the same domain, right? So at the layer 2,
Yeah.
if I want to do a broadcast, right? So it should be OLAP here, right?
Yes.
And then finally it will add the layer 2 header. Okay, this is your layer 2.5 protocol, GR. So it will add its own MAC address, and finally it will add the OLAP, right? So this OLAP is only for the switches. This OLAP is for the last users. Okay, so it will send the packet out here. This will see, okay, this is OLAP, right? That will send the packet out here. Okay, and this interface also. So this user will just drop the packet, because the nature of this packet will always be a reply. So I'll show you this packet also, right, in the packet capture. So the nature of this packet is reply, right? So this user will see, oh, this is a different IP address, so I have to drop this packet. No worries, it will just drop the packet. But if this user will get the packet, this says, oh, I'm having the same IP address, so I have to reply again for the same reply. Okay.
Yeah.
So let me draw this diagram on the GNS3. Okay. And initially I'll show you this packet, the GR packet, and then we'll move to the next ARP request part. Okay.
Okay.
If you get any issues at any time, just stop me there. Okay.
Yeah.
Okay, so on this interface, I will just configure IP address. And once I'll say no shutdown here, right? I should see a packet here, the GR packet. Okay. Okay. Do you see this packet? First of all, the nature of this packet is reply, right?
Yeah.
Correct. Any doubt at this point?
No.
Next thing, let me open this packet. If you see, first of all, what we have here, it will start creating the packet from the GR. Sender MAC address, its own MAC address. Sender IP address, its own MAC, its own IP address. Target MAC address is the OLF, as we have discussed. Target IP address is my own IP address, right? It means I have to just check the duplicacy here, right? And here, if you see the layer 2 information, MAC address, unicast, and destination is broadcast, right? So this is the user MAC address, and that's it. So this was the GR packet. Okay. Any doubt, brother, till this point?
No. So only if we found any conflict with other device, it will respond, like it will also reply.
Yeah, right. Because right now, like the user is not expecting that I will get a reply, definitely, right? Because this is not a request. It means the user is not asking for any kind of information. That is just verifying the information, right? Because if you see this packet is fulfilled, it means nothing is left here, right?
Yeah.
Everything is there, everything. And all these addresses are correct. Everything is correct, right? So we are not asking something here. That is why here this is a reply. It means I just want to verify someone is having this information or not. If you have, so you will definitely give me a packet to me, right? It means, let's suppose I will say Neeraj here. If someone is having Neeraj, that will say, oh, my name is Neeraj also, right? It means that is actively saying that yes, my IP address is the same IP address, right?
Correct.
So that is why the reason here for this reply, the nature of this packet is reply always, right? When we talk about the ARP request reply, that basically request, we are requesting some MAC address, we are getting some reply. So that is why in that case that will be request reply, but here this will be a reply. Okay.
Yeah.
Okay. Any doubt till this point? Anything?
No.
Great. Now I will come to this paint again. Now we'll discuss about that ARP request reply, how that works here, right? So let's suppose I have done the configuration for the IP address everywhere, right? And they have sent the GR packet also. So this has a default gateway address that is 10.0.0.2. This is a default gateway address that is 10.0.0.9. Okay. Now this user want to do a communication to which address? To 10.0.0.10, right? So initially, this user will say ping 10.0.0.10. Now this time the user will be doing that AND operation, right? And that finds, okay, this IP address is not the part of the same domain. So what I have to do here, I have to go to the default gateway. Fine. So what it will do, it will generate a new ARP request. First of all, it is trying to do a ping here. It means it will be creating the packet definitely. So before everything, before even at the end operation, it is creating a packet like ICMP, source IP address, destination IP address. Now, once it will try to find the MAC address, it will find, oh, I do not have any MAC address. So I need to do that AND operation. Fine, it will start doing the AND operation. It will find its own MAC address, that is A, nothing. So it will put first of all this entry in incomplete. Okay, so when you see any ARP table, right, whenever you do a ping, right, and you do not get reply generally, right, so in this case you get that entry as an incomplete over there. If you see, I'll show you that part also, right. So that time the entry will be incomplete over there, right. The device will put this packet on hold. Okay, the packet is on hold now. Now it will do the new operation, that is ARP request. It will say, I don't know this MAC address, and it has done the AND operation and it has fine. I need to communicate to default gateway. Fine. It will generate the ARP request. So the request will be like this. Source MAC address is standard. So source IP is 10.1. Sender MAC is A. Target IP is the default gateway address, right? 10.2. Can you tell me what will be the target MAC address?
Target MAC address, we still don't know the destination.
We still don't know, right? So because it has to put the packet, then only the packet can be out, right?
Yeah, it could be a gateway MAC only.
It could be gateway MAC address. So I don't.
I mean, the destination is for now like it's a gateway only, right?
But
First, he has to reach the
I want
gateway,
to,
right?
if I know the MAC address or the gateway, right? So why I'm sending this one, correct?
Yeah.
Okay. Do you know the mechanism of the DHCP server? The DHCP DORA process.
Yeah.
Whenever the device sends a
Discover,
discover, what it put in the source IP address? Remember? Whenever any of the
source.
user will be getting the IP address from the DHCP server, it has to send a packet, and that's a DHCP discover packet, layer 7 packet. So layer 7 packet, it means it should have some IP address also in the source IP address, right?
So it will keep like a paper address.
No, guys. Before like a CCNP, right? Your CCNA concept should be clear, right? So the things will be more easy to understand. So if I'll talk about DHCP mechanism, right? So at that time, the user will be putting 0000 as a source IP address. Okay, because I don't know my IP address, right? So it will put 0000 just to fulfill the packet. Okay, same here, just to fulfill the packet, this packet, right? It will put like 0000 colon 0000 colon 000. Because this information, who will check this information? Only the end user will be checking this information, right? And then it will put the layer 2 information. The source MAC address is A, the destination is OLF, because I have to send this as a broadcast, right? In the same LAN, correct? So this layer 2 information, who can check? The switches, and this who can check? Only the end user, right? Now this 0000 will act like a fill in the blank. Okay, so whenever the 10002 will get the packet, it will say, okay, at the layer 2 I can receive it, fine. Now the ARP request packet that says this my IP address, fine, but that will say, no, this is not my MAC address, this is something wrong, right? So this is like your ID is CNC 0001 something, and I'm saying like the name here is a random name Rajesh. So you will say, no, my name is this one, and this is my ID, but this is a wrong name, right? So same here, I'm sending something from this user, I'm sending something with a wrong information, or we can say a 0000, right? And once the device, this will receive the packet, that will say, okay, yes, the IP address belongs to me, but this destination MAC address, this target MAC address is not my address. So now I will give you my correct MAC address, and that will be a unicast. So this was the request as a broadcast. The user 10002 will give a reply now, and that will be unicast reply like 10.2 B, 10.1 A, finally here B and A, and this will be a reply as unicast. Okay. Now, Chanakya, your questions, like any doubt till this point?
But there is a hop in between both of them, right? So there is no process.
Yeah, that's a layer 2 switch only. So whenever it will get the packet, it will first of all learn the MAC address over here, the source MAC address, that is A. It will verify the destination MAC address, that is O left. Expecting this interface, right? It will send the packet out to all of the interfaces and it will receive it. Okay.
Yeah.
Any questions? Just check the information again and tell me your doubts. Only this concept should be clear because this is something new for you, I think, right? So this part should be clear to you.
Yes.
So shall we move to the next step?
Yeah.
Okay, great. So what I'll do, I'll just configure IP address everywhere and we'll show you this concept. Okay.
Mhm.
I have to configure this device as a router. So I will, as a PC, so I will say no IP routing. I will say IP default gateway and okay, so I will try to do a ping from R2 from this user to this user. Okay. Do ping 10.0.0.0. Okay, that incomplete entry I'll show you later. I will do a ping to a random address because I have to drop the ping here. I will get the reply, so will not be possible to show you because that will be too frequent, right? So I'll show you the next part, and that part, the incomplete part, I'll show you after this plan. If you see the packet, the ARP request goes to 10.0.02, not to 10.0.0.1, right? Sorry, not to 10.0.0.10. If you see this packet, what that says, sender IP is my IP address, sender MAC address is my MAC address, and target IP is, say, yeah, default gateway address. And if you see 0000, so this is just like, I don't know the MAC address. I want to get the MAC address. That's why I'm putting here 0000, a wrong information here, and the user will give me the reply. Okay.
Correct.
I'm saying here the wrong MAC address. So I'm just taking this as an example, right? This is not a wrong MAC address. This is the concept we have. Whenever any of the device gets the packet with 0000, that will get to know I have to fill the information here. Okay. Clear this one?
Yes.
Okay, great. Now, if you see the reply, that is unicast, and I'm getting the MAC address of the user, right?
Good.
Great. And one more thing, if you see the opcode, the request has a opcode 1. The reply has a opcode 2. Why these opcode? Basically just for the devices. I can see this is a reply. I can see that's a request. But for the device, if the opcode they see as a 1, right? They see as a request. If the device sees the opcode as 2, they see as a reply. Okay. And then we have the request reply. And if you see, the packet was on hold, that is dropped, right? 1 reply, 2 reply, 3 reply, 4 reply. I got only 4 reply here, right? So if you see here also, the first packet was dropped. So the first packet dropped just because of that request reply mechanism. Okay. So IPR. I have the MAC address here. Look here. I don't have that address 10.0.10 in my domain, right? Because I know if I want to communicate to any of the different subnet, I need to go to my default gateway, and the default gateway MAC address is this one. So no worries. Now let me do a ping to a random address 10.0.0.5, let's suppose. Okay, and now I can show you that entry as incomplete. You see this one? The entry is incomplete, right?
Yeah.
Okay, can you tell me one thing? Just silly question maybe, right? In the ARP table, why we are not getting that address 10.0.10? Why I'm getting here 10.0.5 but no 10.0.10? Any idea?
So because it's not on the same segment, right? So
Exactly, because ARP says ARP is for the local broadcast domain, right?
yeah.
So whatever address we have in the local broadcast domain, I will be working only for that, right? But for the addresses belongs to the different domain, no, I will not never take care of that part, right?
Correct.
Okay, cool. So this is how basically the ping will be working. And the very first packet, we have done a discussion on the very first packet, the second packet, the third packet, the complete mechanism we have done. Okay.
Yeah.
So brother, like if you have any doubt, anything, okay, you can ask. All good?
Yes.
Okay, great. Just 1 minute. Let me have a sip of water. So now let us start with ping. Okay, so bro, like why we are doing these basic discussion, because in future, like we'll be doing some ping, right? We'll be checking the packets over here, there in the protocols, right? And these basics are required to understand that advanced concepts. Okay.
Sure.
So whenever we do a ping, we see some different options, right? So what we can talk about only IP, IPv6, we can talk about MPLS only. Okay, so these three things we can talk about. Okay, but when we start doing a discussion for IPv6, I can take this one. When I start a discussion of the BGP and MPLS, I can take this one. But right now, we are just checking the IP mechanism. So I will just take this option. Okay. Okay, guys, one more thing. If you see the trace route here, that is for IP, that is for IPv6, that is for the MPLS. But nowadays, the new iOS we have, we can do a trace to the layer 2 address also. It means we can do a trace route to the MAC address also. Okay. Yeah. So that part also I'll show you. Like I will try to arrange a new iOS, right? And I will try to show you the use of that part. Okay.
Oh.
Okay. So let me focus on this ping IP. Ping IP. It is asking for the target IP address. So the target IP address is, let's say, 10.0.0.0. Enter. Repeat count. So by default, it has a repeat count of 5. You can do the modification also. Let me say I just want to send a single packet. Fine. Datagram size. So this is the size of the packet, right? So now why we need to change this size? So brother, like, can you just give me any idea or any use case where we need to modify this size? Any idea?
If we have any latency issues, like users reporting.
Okay, latency issues, like I think this datagram size will not help me out.
I mean,
Okay, I will just draw a diagram, a simple diagram, and we'll try to explain you the concept. Okay. Okay, do you know this one? Ever used or Zscaler
yeah, it's a cloud-based proxy.
tool, right, for the users?
Yeah.
So let's assume I'm here, I'm connected to my company VPN. This is cloud, this is again cloud, and that Zscaler server is here. And this server is hosting the Zscaler application. Okay. And I have used a VPN connectivity to communicate to this server. Okay. Now I have done few migration over here. Let's suppose this was working fine, right? And now I have done few migration over here. I have changed the solution over here, right? Now the users are saying, the users are asking to me, we are not able to access the Zscaler, but they are saying whenever they do a ping to Zscaler IP address, that is reachable, right? But whenever we are trying to access the Zscaler application, we are not able to get the UI. Let's suppose they will be having some Zscaler application, and we are getting over there connection issues, connection timeout that we are getting over there, right? So earlier it was working fine, but after that migration, that is not working fine. We have done some new changes over here, right? We have done some task of MPLS, some new tunnels over here, right? But the ping reachability is there, right? But that application I'm not able to access. So what happened in the background? Whenever we do a ping, the datagram size is only by default, that is 100, sorry, bytes, right? But the application will be having a different size of the MPU, right? Let's suppose this has a size of, let's suppose 1450 bytes MPU. Okay. And the migration I have done here, let's suppose I have done MPLS over here, I have done the GRE tunnels, I have configured over here new GRE tunnels, right? So when we add the new GRE tunnel, it will add one more header over in the packet. Whenever I will add the GRE, sorry, the MPLS, it will add might be two headers over there or a single header, depends on the diagram, right? So because of that, the size of the packet was more than 1450. Okay. And it was getting the packet, or in between devices was getting the packet with a higher MPU, and they were dropping the packet. Okay. Because this Zscaler information or that application needs a packet that should have a MPU 1450 or less than 1450, right? Because if I get a packet with a higher MPU, right? So at that time, I will not be able to handle that part, right? Or that Zscaler application, correct? That can process this much amount of data at the same time, right? So that is why the ping is reachable, but not this is reachable. So that time what we do a reachability check by what we say. Now I will try to send a packet out here, a ping packet with 1450 byte, and will put a field that is do not fragment bit, DF bit. Do you know about this bit? DF. Okay, when you will like learn the IP header, right? I can share a video of the IP header. In the IP header, we have a flag. There are three flags. One is your M bit, one is your DF bit, and one is your none, that is not used. Okay, M is your more flag, and DF bit is your do not fragment. So by default, that is 0. It means anyone can do the fragment. But now I will set it here, do not fragment. It means throughout the destination, no one can do the fragment of this packet, because let's suppose if here we have a small size, right? So that can do the fragment. It means now this device will get two packets, and that is happening here. I'm sending a packet out here, and because of those tunnels, because of those MPLS thing, right? The packet size is, let's suppose, 1900, and now this device is getting two packets, right? One is of 1450, one is of for the remaining size, right? And this application says I can receive a single packet only. I cannot reassemble these packets. Okay, and that is why the application is not reachable, right? So I will say to my PC, please send the packet out with 1450 bytes and set a DF bit to 1. It means do not fragment. It will try to send the packet out here, right, throughout the network. So that packet will be successful. But now when I will say 1500 bytes and DF bit is 1, but the MTU size here what we have is 1450 only, right? And in that case my packet will be dropped. If the packet get dropped, right, so I will get to know someone is here that is dropping my packet, or someone is adding some new extra information over there. Okay, some new headers over there. So that's a big design. I'm just taking an example, right? Why we change the size of the ping, why we set the DF bit. So this is just a one example of those examples. Okay, those diagrams if we talk about. Okay, so whenever we need the path, yeah, tell me.
No. So DF is when we mention do not fragment, we are saying like do not chop the packet like
exactly. Correct.
Okay.
Yeah.
Okay.
It means I just want to verify all the routers in the between me and destination are having the same size or not. If someone is increasing the size, right, so the packet will be dropped in the middle, right, and I will get to know some issues we have in the MTU. Okay. So I can make it 1000 also. Timeout. So I can set a timeout also. It means if I do not get a reply within 1 second or 2 seconds, I have to drop the packet and I have to reinitiate the new packet. I will set it to extended commands. Now we can add few more things here, as I told you, like the DF bit and those things, right? So yes, extended commands here. I want to set it. Bro, just 1 minute. Sorry. Okay. Yeah, so it is asking for the source address or interface. Okay, if you know, by default, whenever a router or a PC will be sending a packet out, right? So the source address, it will take the exit interface address, right?
Correct.
Correct. Now you can even change that information. Okay, let's suppose a router has 4 interfaces. Okay, and the user want to send the packet out with a loopback address also, right? Loopback address or any other interface address that we can do. Okay, but right now we do have the single address here, so I will just say use the same address. I can put the address or interface also, but I will leave it blank. Type of services. Now this is basically, let's suppose you want to verify your packet. Let's suppose your application use a toast bit, like your toast bit, let's suppose that is using 2 3, let's suppose 3 is for the critical, I think, right? Quality of service I'm talking about. So let's suppose your application, Zscaler application, is using the toast bit 3, right, throughout the network, but you have done some migration with the ISP also, right? But at that time the ISP has not done any modification, or we can say it has not done any task for this information, right? What you can do then, you can apply the bit here and can check throughout the network. It means like whenever your destination device will get the packet, right, what toast bit it is getting. If that is getting 3, all good. If that is getting a different bit, right, it means the ISP has not done its task, right? It has to apply some configuration. So whenever it will get a packet from here with a bit 3, it should do copy and paste. It should not like replace with a default one. Okay, with a routine class. Default one, it says a routine class. Okay, that's a 0 1. Yeah, because even at that time the ISP should be involved in the migration activity, right? And at that time, the ISP should do this task, like whenever I will get a packet with the toss bit 3, it should convert it to 3 only. Okay. But now again, that has a big concept over there, because whenever ISP use, right, here on the customer end, they can use n numbers of combination, but the ISP can just use 8 combination over there, right? They do not have much options to convert, right? So that's a different part, but yes, they have to do something at their end. Okay. So this we can use, let's say 3. Set DF bit in the IP header. If I'll say no, no is by default. I will say yes, I want to set it. Validate data reply. Okay, this is just a validation data reply. That is nothing for the task, right? And even we never use this part. Data pattern should be in the, yes, hexadecimal, fine, no worries. Lose strict okay, about these things, once I will start the URPF part, I'll discuss. Okay, because these loose mode, strict mode is a part of the RPF. URPF, sorry, unicast reverse path forwarding check. So I will set it to none. Sweep range of size, no, I don't want to increase the range, fine. And we are sending a packet. Now I'll go to the packet capture, will show you the packet. If you see, I have a single packet, right? I do not have 5 packets. Let me open this packet. I will open ICMP initially. If you see, the size length is 972, right? We have set it to 1000, remember?
Yes. Yes.
Okay, but if I'll show you here, this will be more than 1000, that will be 1014. Do you know why this is 1014? Because whenever I will send a packet out there, I have configured the size, the datagram size should be 1000, but it is 1014. Do you have any idea why this is 1014, not exactly 1000?
It add another information on top of, right, the IP address.
Okay, that is MAC address. Okay, the layer 2 information. If you see here, destination MAC, source MAC, and this is a type field of 2 byte. So 6, 6, and 2. Complete contains 14, right?
Yeah. Okay.
Cool. So whenever we say 1000 bytes over there, that is including your data and your IP header, because that is a MTU. MTU, it means that contains your packet size till L3. So till L3, there should be only 1000 bytes. Okay. So 972 is here. It means the remaining one. How many are remaining? Like 28 is remaining. So the IP header belongs to the 28 bit size. Okay. Clear?
Yeah. But Neeraj, like by default, it's like everywhere it's a 1450, right? What is the point of just having 1000?
No, 1000 I have just taken randomly.
Okay.
Randomly.
I mean, it's the same MTU size, right? When 1000, it's not like 1450 packets.
No.
Right. Okay.
If you see, I told you, when you have the reserve bit, we never use. Then we have the DF, do not fragment. More fragment is not set. So DF bit is set. No one can do this fragment. Okay. And okay. If you see, the toss bit is here 3.
Okay.
Right.
So one more question, like, sorry. Toast bit is like related to QoS, or like
Right.
giving the priority to that packet?
Exactly.
Okay.
So this packet was successful. Now I'll just do a small modification. What modification I'll do? I will go to R1. You see, I'm getting some issues over here. This says empty mismatch. Okay. The packet is not successful. And if I see the reply also, what I'm getting here, destination is unreachable, because that is not able to send the packet out there, because if you see the real answer, that is fragmentation needed, right? And when we get the fragmentation needed, right? So you can just directly see your ping reply output that says M, that is your fragmentation needed. Okay. Some MTU issues we have in the path. So any doubt till this point, brother? Anything?
No. Yeah, it's like I never tried. Like it's a good session for me. Like it's helped a lot of troubleshooting. Like
You're learning something new, right, today?
yeah, exactly.
Yeah, because whenever we do the troubleshooting, right? So just a ping 10.0.10 is just not a ping, right? So in this way also we can use, right? In the trace route also we have few more new things to verify the information, to do the troubleshooting, where we have the ACL, where we have the packet drop, those things we can see, right? So any doubt in the ping mechanism?
No.
Okay, this ping is not done yet because this was the ping when we do not have the MPLS segment, or we can say that MPLS design. When we have the MPLS design, let's suppose you're working in the ISP company, right? So that time this ping won't give you the exact answer in the ISP mechanism. Okay, so when you're working as a ISP engineer, right? So you will never run this ping IP directly, never. You will run ping MPLS. Okay, because that time you will be using some labels, okay, and you have to troubleshoot where your labels are dropping, not packet, right? Because the reachability will be there in the ISP, definitely. We can have multiple paths to reach multiple neighbors, right? But the label path should be there, and the label path we check using the ping MPLS. So that's too far thing, right? We'll discuss once we start the MPLS and BGP. Okay, so I'm sure no doubt till this point, right?
Yes.
Great. Okay, let's take a break of 5 minutes, okay, and then we'll start the trace out. Okay.
Okay.
Okay, shall we start?
Yes, Neeraj. Yeah.
Okay, great. So now let us talk about the trace route. Okay. So do you have any idea about this trace route? Like what is the mechanism behind this one? How many ways we have to use or anything, whatever you have.
Trace
As per
is like
my
like
knowledge,
it goes like hop to hop, like from the source IP to the destination IP, like whatever path it takes, like hop to hop.
Okay.
and every hop it add a TTL value.
Okay.
Mm.
Initially, what TTL value would start with?
Let's start with the 0.
0, really? 1. Well, at least it
Yeah, I
should.
mean 1 to 255. Yeah.
Right. Okay, so I'll just repeat the same things again, and we'll add a few more things from my side. Okay.
Okay.
And in case any issues, just stop me there. I can start again from the scratch. So we have a router R1. We have a router R2. One more router we have connected is R3, and finally I'm taking as a R. Okay. So we do have a user connected here. One more user here we have connected. Okay. So in between the addresses we are using, so I will consider whenever I will draw any diagram, guys. Okay. Or in future I will like use OSPF, IGRP, anything, right? So if that is 1 and 2, R1 and R2, so the subnet would be 12.0.0. Okay. Here we have 23, 2 and 3. So the subnet would be 23.0.0.0. And the address would be, if this is R1, so this is 1, R2, this is 2, R2.2, dot 3, dot 3, and dot 4, like this. Okay. So we can easily identify. Let's suppose in my trace I get 3. It means that is R3. If I get 10, that is R10. Okay. So just because of that concept, just to get the clarity at that time, right, we are taking this kind of subnet series. Okay. Any doubt till this point? And subnet range I'll be using throughout the complete session till the last class of this session. Okay. So if that is 1 and 2, subnet will be 12, IP would be 1 and 2, like this. If this is 3 and 4, subnet would be 34.0.0.0.0 and address would be dot 3 and dot 4. This is clear?
Yeah.
Okay, great. So here we have, let's suppose 10.0.0.1 IP address. Here we have 20.0.0.1 IP address, right? Now, whenever we use trace, so I'll just note down few points. Whenever we use trace, by default, router will or a PC will send a UDP packet to destination with TTL count 1 by default, right? So that's a UDP packet. So if that is a UDP packet, right? So there should be some UDP port number, right? So they use a range of UDP port number starting from 33434 to 33464. Okay, these are the range of 30 port numbers. These are never used by any application, any software, anything. These are reserved for the trace outcome mechanism. Okay, so the device pick a address or we pick a port number 33434 initially, and one by one it picks one by one all the port numbers. Okay, and send the packet out to the neighbor. And whenever the neighbor will try to reply, they use ICMP to tell source, to tell the destination is unreachable or both things happens in a different case. Destination is unreachable, or destination port, sorry, not destination. Destination port is unreachable, and or sorry, not and or TTL expire. So we have two things here. We can get a reply. A reply can have TTL expire. A reply can have unreachable port number, right? So whenever the originator gets a reply with TTL expire, it send, first of all, what it will do, the very first task, it monitor, or we can say it note down the IP address in the output. Second thing, it send the same packet again with +1 TTL to destination, right? And this will keep happening. Keep, like, the neighbor will get a packet that will give me a reply, TTL expire. It will note down the IP address. The next router will give me a reply, TTL expire. After that, again one by one. And whenever the originator gets a reply with destination port is unreachable or service unreachable, port number tell us what is the service, right? So if the device gets a reply with destination port is unreachable, service unreachable, right? The device put the IP address in the output and break the trace, and it stop the, basically it will stop the trace route. So until it is getting TTL expire, it will keep doing the same task one by one. We'll add the address, we'll do +1 in the TTL, we'll send the packet out. Once the device gets a reply with destination port is unreachable or the service is unreachable, the device will just put the final IP address and break the trace out mechanism. Okay. Just check the theory part again and tell me if this is not clear.
On what condition TTL will get expired?
Okay, this is basically whenever the destination gets the packet. Let's suppose it is sending a packet out. Here, the TTL would be 1, and it says, okay, whenever I will get a packet, I have to decrement the TTL first. That's a normal mechanism, right? That will do a decrement 1. This will be 0. This will give a reply TTL expire. It will do a 2. 1. It will say -1 0. Now I will say TTL expire. Okay.
Oh, okay, got it.
You got the point, the TTL expire mechanism. I'll come to the lab part definitely, but just this theory part should be clear.
Okay.
All clear?
Yeah.
Okay, great. Any doubt now? Anything? Shall we move to the lab part? This one?
Yeah.
Okay. Now, okay, so initially this will create a packet, UDP packet, right? UDP packet will be there with a port number. As I told you, random port numbers will be there from that range only. The source IP is 10.1. The destination IP is 20.1. And here it will put the TTL, that is 1 by default. It will send the packet out here. This will say, oh, now I have to decrement a TTL, right? So it will be 0. It will give a reply with this information. So that is, I suppose, 10.10. It will send ICMP reply. it will send ICMP packet to tell the neighbor that TTL is expired, and it will put the TTL that time is 255 TTL. Okay. So whenever we get the reply with ICMP, the ICMP packet will contains the TTL is 255, because that device don't know how far that is, because the device R1 has just received a packet with TTL1. The device really don't know the destination is 10 hops away, 20 hops away, or 255 hops away, right? So that is the reason here, whenever the device give reply with TTL expire, they use the TTL 255, so the packet can go to the last router definitely. Okay, so they just make sure the packet should move to the real originator. Okay, and once the device gets the packet, it maintains IP address. Okay, so I'm getting a reply of TTL expire, that is 10.0.0.10, and one more query. They send actually 3 packets at each hop. Okay. Okay. Clear? Any doubt from your side?
No.
Okay, great. In the same way, it says, oh, now TTL is expired. I have mentioned the IP address. I have to do +1. So this time it will send the packet with 2, the same packet with 2. The packet will go here. Now it will do a decrement, 1 minus 1, that will be 0. Now it will get a reply from here, that is 12.0.0.2. Same, next time it will put 3 here. We'll send the packet out till this point. This says, okay, now that is 1 minus 1, because 3 minus 1 is 2. 2 minus 1 is 1. That is still routable. 1 minus 1, that is 0. Now that is not routable. It will reply. Now I'm getting reply with 23.0.0.3. It will put 4. It will keep doing the same task. Will keep doing. It will give reply. It will get to know 34.0.0.4. Will keep doing the same task. 5. Now it will say, this is okay. This is my IP address. 1 minus 1 will be 0 definitely, but I will not say TTL expire, because that packet is for me. I can have it, right? So it will say, yes, this is my IP address, this is my IP address, this port number. No, I do not have any kind of services related to this port number. So this will reply service unreachable. And once the device gets a reply, service unreachable, the device mentions the information over here and break the mechanism. Okay, so this is how we got the IP addresses over here. Okay. Any doubt till this point? Anything?
No.
No. Guys, if this is clear, then I can move to the I can like add few more points here. If this is clear. So shall I move to the next point, or any doubt till this point? Shall I move to the next point?
Yes.
Okay. Same diagram I'll use. R1, R2, R3, R4. We have a user. Now I will not talk about the TTL point. Okay. Let's suppose this is the address that belongs to 20 series. I have done the IP addressing, the routing here, that is 20 is reachable via R2, 20 is reachable via R3. I have not done anything here, but I have to do this to this router also. 10 is reachable via R1 and 10 is reachable via this router, correct? And this says also 10 is reachable via this router, right or wrong?
Yeah.
Okay. Let's suppose I have not done this part. So whenever we do a trace route, right, what kind of reply we get sometimes is, sometimes in the trace route we get star, sometimes we get H, sometimes we get A. These are the common reply methods that we have, right? So I will talk about these three things. What are these three things? Okay. So in this case, this says the source is not reachable. This says destination is not reachable. This says ACL is there, that is blocking your traffic. Okay. So let's suppose I will do a trace out from here. I will get a reply from this way. Fine. I'm getting reply from R1. And then I'm getting star, 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 star. Reason being, this device R2 do not know how to reach source address, that is 10.0.0.0.0.1. So whenever this user will send a packet, right, the packet source will be 10 and destination would be 20, right? And whenever R2 will be checking the table that says, oh, whenever we do a trace route, first of all, I'll just give you clarification. Whenever we do a ping, let me go down here. Whenever we do a ping, the devices just check a destination address. They never check the source IP address. But whenever we do a trace route, the device itself, first of all, check the source and then it check the destination. Okay. Now, whenever R2 will be getting the packet that says, okay, the source is reachable or not, it will check the routing table. No, I do not have any path here. So what I will get here, I will get star, 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 star. It means I will get to know. Till this point, everything is fine. But after R1, the router we have that do not know how to reach source address. Okay. Now, let's suppose I have given 10.0.0.0.0 address, the route here towards this way. Fine. In the next trace route, what I will get? I will get R1. I will get R2. But this time R3 do not know about the destination. That knows about the source, fine. That don't know about the destination. Now that will get R3 H. So whenever you see this kind of mechanism, it means till R3 source is reachable, but R3 don't know about the destination route. Okay. This is clear.
But Neeraj, like when the packet is going, but why can't it come back when because of like kind of asymmetric issues? Or?
Okay, asymmetric issues. Whenever we have the asymmetric issues, we get the reply from somewhere, right? We get the reply. But this we are talking about like we do not have any path here, right?
Yeah.
It means like the router itself do not have any path or any route to reach the source and destination like that. Okay.
Okay.
Whenever we get star, it means after that router, the router it don't know about the source. When we get this one, it means this router itself don't know about the destination. Okay.
Yeah, but so my question is like when we tracing out like it reaching the R2 means it can't come back the same path. So the reachability.
Because even R2 don't know. R1 is sending this packet out here. If R2 do not know, that will just say to R1, I do not have any path. Okay.
Okay.
Yeah.
Got it.
I'll show you this practical, definitely.
Okay.
And same for HH, it gets here, but that says, okay, that is reachable, the source is reachable, but I do not have any path to reach the destination. That says destination unreachable then, using ICMP. Okay. And if let's suppose both are reachable, 20 is here, everything is reachable. But if by mistake I will configure here ACL, in that case I will get AAA. And whenever in the trace route, let's suppose I'm getting a reply from R1, R2, R3, and then I'm getting AAA. It means some ACL we have on R3 that is blocking my traffic. Okay. Now just tell me any doubt in the theory part, then I'll move to the lab part.
No.
Okay. So let us move to the lab.
Got it.
So I'll be using these routers. One more router I will add. And I'll be using a random routing protocol here just to check the mechanism. I will just create a loopback address also. I hope you have idea about the loopback address, right?
Oh, yes.
On R2, I will say IP route 4444. That was so in this case, let me just configure a route that is belongs to port 2.5 and 3400 have 2 by 0. Okay, so let me try to do a trace out from R2. Okay, and we will identify where we have the issue. Trace 4444 using source loopback 0. If you see, the traffic is going till 10.002, and who is 10.002? That is R1, right? And I'm getting star star star. It means till this router everything is fine. I'm not getting a reply from R3. That R3 do not know how to reach 2.2.2.2. If you see here, do you see what I'm getting here? Let me open this packet. This we are sending, not getting a reply. So if you see till this point, I'm getting a reply, but here we are sending a packet out to this one with a more TTL. If you see, the TTL counter is here more than 1, that is 3, but we are not able to get reply because we are having a timeout of all the packets now, right? We are not getting any reply of the packet, and that is why here I'm getting star star. It means if I will not get any reply, it means the device do not know about the source address, right? These are packets only from R2 to R4, not from R4 to R2, right? Correct? And
Yes.
you see here in between, I'm getting a reply from 10.002, right? It means R2 is giving, R1 is giving me reply. The time to leave exceed, right? And if I open this ICMP packet that contains TTL should be 255. The TTL is 255, and that is saying for this packet, the TTL is expired, right? That is containing this packet also, right? That was the source, this was the destination, this was the port numbers, right? But destination, the time to leave exceed in that transit, okay? For this complete packet. Now, so now let us fix the issue, okay? How we can fix the issue? I'll go to R3 and we'll tell how to reach 2.2.2.2. But before that, I will remove the destination address. This one, IP route 2.2.2.2, 255, that is reachable via. That was, what's that? 10.009. Okay, let me do a trace route now. And if you see, everything's fine, and then 10.010 is saying H. It means this router knows about the source. I'm getting a reply from that router, but that router do not know about the destination. If you see the trace route here, Look here, 10.0.10 is saying me the destination is unreachable, right? The host is unreachable. It means the device itself, 10.0.10, do not know about the information, or we can say about the destination, right? Once the device will get to know about the destination, I will start getting the reply. And once I will set this route over here, I will start getting reply. But this time I'm getting a new error. After this, I'm getting star. It means after this device, whatever device we have, that do not know about the source again. So what we have after this, that is R4. Even R4 don't know about this part. So let us configure IP route 2.2.2.2.245.245. So here we are doing the configuration, but in the live network, I will make sure why this router and the protocol do not have this route in the routing table, right? So that time I will do that kind of troubleshooting. I will check the protocol. I will check the information why we are not getting, right?
Yeah.
Look here. Now the trace out is successful. Now somewhere in between, I will configure a ACL. So let us configure on R3. Okay. Access list 1 deny ACL. Whenever we do the migration, some by mistake, like we put some deny permit action, right? And because of that, the packets get dropped. And in the trace route, we can have the idea, do we have any ACL or not over there? Okay. F0 by 0 IP access group 1 N. You see, I'm getting A. It means everything is fine till this point, but they after this router we do have some issue. Sorry, on the same router we have some ACLs, and you have to cross check that part. Okay. So these three things we have here, right, to discuss for the trace route. So any doubt till this point, anything? So we have done the packet flow. We have done the ARP request, ARP reply mechanism, and GARP also. We have done ICMP, how that ICMP and the ping is working in the background, and how we can use it for the trace route, and the DF bit also we have said. And finally, we have done the trace route and the features of star, the feature of H, the feature of A also. These things we have done. So anything, any doubt from starting to till this point? Tomorrow we will start with URPF, and we'll be doing a discussion of so guys, you can tell me, like, if you have any doubt, you can ask. All good?
Yeah.
Great. Okay, so let's wind up the session, right? And before the next class, right, just go through these things, right? And if you have any doubt, we can have a discussion on that, right? And just make sure you have some idea about these two information, URPF and PBR. Okay, so the session will be interactive, and you can just learn the things frequently. Okay.
Yeah.
Okay, guys. Thank you. That's it for the day.
Thank you.
Thank you.
Okay. Bye. Take care.